So the next thing is to look at a process. Now, in Chemical Engineering 101, which I taught at Penn State, it's called Chemical Engineering 210, which I've taught many, many times to the intro class. We say we have a reactor. So we have some fresh input into this reactor. We say it goes to a separator. Part of this goes out to the customer. Part of it we recycle because all of the ideas that went into here, all the fresh materials didn't react. And so we don't want to waste those, so we bring those back. So we have a recycle. And somewhere in here we have a purge. Over it all, we have process control. This is the same process that I see innovation working at. First, we want to identify this piece, or at least hypothesize it, the future voice of the customer. And we need to figure out what input do we need in order to get there. So we're going to need certain concepts. We're going to need certain ideas. We're going to need certain experts, maybe external to the company even at first. They come into the reactor. Now, the reactor is a generative unit. That's where the transformations take place that produce valuable products. Here is where I see the valuable questions and the multiple hypotheses forming. I think they're the hardest part of research, is coming up with good questions and hypotheses. It's where I struggle with my PhD students the most to get those moving through. And even when we're working with companies, it's where I see them struggling the most to define clear questions and pose multiple hypotheses. This now goes to the evaluative unit, which is where separations occurs. This is where you do your laboratory tests. This is where you do your pilot tests. This is where you go to your customer to try out some different marketing, some ideas in the marketplace and see how valuable they'll be, see if they'll do pre-orders. And this is where you go to evaluate each step along the way. Those pieces that go through to the customer, to the future voice of the customer, go there. The recycle comes back. So there's some ideas we say, well, we're going to need a little more work on those, and they come back. Any ideas that we don't see, even if we've invested a lot of money in it, if we have ideas that don't look like they're going to be the best we have, we should purge those. They're inert. We purge the inerts out of the system and the toxins so that they don't build up and destroy the whole process. These come back to the beginning and they go back into the generative unit. So this is how Chemical Engineering 101 works. This is a well-functioning innovation process. What happens many times? Well, if here we have stage gate who in practice or even by threat of action acts as a tight valve here, this recycle starts to get thicker. And remember, recycle is like inventory. It's what you paid for, but you're not receiving any profitability from it. You're not selling anything from it. So this recycle starts to get thicker. The purge sometimes ends up over here at the customer level. This is the worst place for us to end up, of course, because what that means is that the customer is purging it. And not only has your product failed, but your brand has failed, and it detracts from the value of your brand as well. So the purge can sometimes end up in the wrong place. The recycle has gotten thicker, and now, because your capacity, unless you're hiring a lot more people, which you don't often see, your capacity of your generative and your evaluative steps has not changed. It's now filled up with recycle. And this fresh input, starts to get cut off, and it becomes a very thin loop. In fact, negligible in some cases. Very few companies have a deliberate program of their innovation team taking courses and attending conferences, bringing back ideas, not just going to the conference, but bringing back ideas, bringing in experts systematically. The systematic and deliberate input, the systematic and deliberate input starts to die. And that means you're left with the ideas you started with. So the reactor now is consumed by this recycle. It goes over to here, and this loop, this unit operation, this evaluation starts to get thicker and thicker and thicker, because we start to spend more time in the laboratory. There's no new ideas coming in, so there's nothing to generate now. So we spend more time in the laboratory, as if that extra time in the laboratory is what's responsible for adding value for the customer. The primary purpose of research and development is not to spend time in the laboratory. It's to advance innovations for that future voice of the customer. That's such a key point. Our job is not lab experiments, but to test ideas and to get rid of them, to get rid of the losers. So as this gets not only thicker, but I'll put some marks in it like this, it becomes incomplete. Incomplete because frequently this evaluative step, as we discussed earlier, is just from one perspective. It might be just from the marketing team's perspective, or just from the R&D team's perspective, rather than holistically, because the whole chain is required to get an innovation out the door. So this is both, it gets both thicker and incomplete, and you can see the whole thing is getting distorted. The whole thing is getting distorted. And that's where Goldratt's bottlenecks start to come in. Now, we can look at a number of bottlenecks, but I want to just focus on a few. I want to focus on this stage gate and recycle as one. I want to focus on the integrated innovation team as two. I want to focus on the valuable questions as three, and the deliberate input as four. There are many others that we could look at here, but those are the first that I want to look at. So the first is this stage gate one, which we've already discussed it in some ways. We've discussed how as this acts as a valve, the stage gate process, not only is it siloed, not only is it primarily evaluative, but it's serial, it's slow, and it really kills morale. People are not only does this act as a valve when products reach the stage gate and are rejected, but the threat of that happening can be also be hurtful. In one case, I was working with a client, and they were talking about doing work, and the legal department had told them that they had enough examples for their patent, but the researcher kept going, kept running experiments. He said, I think we need a few more experiments. And I can appreciate that perspective. As scientists, we're oftentimes dedicated to getting things right, but having this integrated innovation team says, hey, let's listen to the IP person. When they say we have enough examples, let's move on to the next test, because there are many more valuable things we have to get to in order to move innovations out the door. So this stage gate is a real challenge. Second is forming this this integrated innovation team. How do we do that? Who does that? Well, who does it could start with anybody, really, and it could be somebody from marketing. I find that R&D is a good place to start in many cases, just because the people in R&D seem to have an easier time understanding some other ideas, and sometimes people do understanding R&D ideas, and so that's a nice place to start. But it doesn't have to be a VP to do this. It can be anyone on the team who starts to gather people and say, hey, let's look at some ideas, start over lunch. Take a look at these ideas. And they start to pull things together. Next thing you know, they're talking to multiple people, and next thing you know, you have a team that includes somebody from legal, somebody from regulatory, somebody from various categories, so that they can start to push things forward. Now, one of the challenges here is who gets the credit. And this is one place where leadership can play a big role. If leadership is willing to say, hey, let's spread the credit appropriately, but there are other methods for doing this. Spreading the credit is who owns it, in other words, can be a real challenge. So this is the second one, this integrated innovation team. The third thing is with the questions, which we'll get to in a little bit, and also the concepts, the new concepts, which we'll get to in a little bit. So I said we would go through, look at the philosophy, which is process manufacturing. Look at the processes, which in this case is a standard chemical engineering flow diagram, a process flow diagram. Finally, now we're at the practices. And so this is the last piece.